Class, and welcome to lesson 1.5, Central Tendency. Today we're going to take a look at our first statistical information attached to one variable stats, okay? So now we're getting to the number crunching. So you'll definitely need a calculator for this. So if you need to pause and get a calculator, by all means go and do so. So for our warm-up, ladies and gentlemen, 1.5, we're going to take a look at three central tendencies, which is the mean, the median, and the mode. Hopefully you've done this in past years. If not, we will go over a refresher for you. So mean is like the average number, okay? And the symbol we use in mathematics for mean is a lower x with a bar across it, okay? So to do the mean of these numbers, in the past you've been taught to add them all up. So 13 plus 18 plus 28 plus 17 plus 18 plus 16 plus 8 plus 16 again plus 15 plus 29, and then you add them all up and you divide by the number of data points. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure you got 10 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the top, on the numerator. Okay? And always show your steps. So do the sum first. So basically make sure you total that up first before you divide. Okay? So you're going to get a sum of 178 divided by 10 and plug that in your calculator and you're going to have 17.8. So the average number is the mean of 17.8. Okay? Okay, so that's the average. Now the median. Okay, so the median is the middle value, for those who can't remember this, middle value when data is placed in order. We're going to say in numerical order. Okay, numerical order means you either go from greatest to least or least to greatest. I prefer to go from smallest to largest. Okay, so you got to be careful when you're doing this, folks. So I will just put this like this, and then I will do them. So the smallest number I see first is 8. Then the next one is 13. Then I go 15. Then I go 16. And I go, oh, there's two 16s. Be careful there. Then I go 17, 18, and 18. There's two 18s, 28, and 29. Okay. So normally, ladies and gentlemen, you cross out and you get to the middle. So I take the two outsides, they cancel out each other. Then I do the next two. And I do the next two. And I do the next two. And normally you choose the middle number. However, in this case, we have two middle numbers. So if you have an even number of data points, this is what you have to do. You actually average the middle, and you have to show this works. So the median equals 16 plus 17, and you divide by 2, okay, which gives you 16.5. If there was an odd number, ladies and gentlemen, you would just cross and circle in the middle number, okay? So it depends on if there's odd or even, okay? And the last one we'll take a look at in the warm-up is our mode. So mode, ladies and gentlemen, equals is the most frequent occurring number. Or value. Okay, so scan the list of data, ladies and gentlemen, and take a look. Which one occurs most often? Well, there's actually two. So it's going to be 16 and 18. And if there's two, we actually call this bimodal. Okay? People always ask the question, what happens, Miss R, if no numbers repeat and they only occur once? Then we call it no mode. Okay? If there's three numbers that occur the same amount of time, then we call it trimodal. Other than that, we don't keep going on with special names. Okay? All right. So now let's take a look at what you should have done. And now we're going to put into a data perspective. So you're going to see some Greek letters, some lowercase letters, some uppercase letters. You're going to need to get your formula sheet out. So either the formula sheet I gave you on the first day of class, or grab the last sheet, last page in your textbook at the very back. We're going to use the front side, and we're looking for one variable statistics. You're going to see a bunch of Greek or unfamiliar terminology, and I'll show you what each means, each symbol means, okay? All right. So now that we're taking what we've learned in the past, now we're putting it into a data perspective, okay? So compute measures of one variable statistics, okay? So usually small letters are used to describe samples, okay? So you're going to see lowercase x with a 1 below it, y to the 1 below it. You're going to see lowercase n, mean with the data point, with the bar cross, okay? And a lowercase s, okay? Whereas capital letters and Greek letters are used to describe the entire population, okay? So see capital letter with an I, capital letter, capital N. This Greek symbol like this, we call this mu. You're going to see it often, so you'll learn that. Okay? And then you're going to see this other one that's called sigma. Those are two Greek symbols that we're going to see. Okay? So just scan your formula sheet and take a look at these. Okay? All right. Notice for your test, folks, and I'm going to look for proper communication. If you're dealing with a sample, you're using the lowercase letters. If you're dealing with populations, then you need to use the capitals. So your formula sheet will always be allowed to use. You don't have to memorize them, but you have to know when to choose which one. So you have to have proper language. You have to be able to understand when's my data a sample and when's my data population. Okay. Keyword for population is census, or all the data points. Okay. All right. Our text uses X to represent the random variable. So what we're trying to study. Okay. And here is a letter, right, a Greek symbol here, and this means the sum of something. Okay. You'll actually see that on spreadsheets, ladies and gentlemen. So if you're familiar with any of the spreadsheets, you press that button and it adds things up, okay? So what this means, folks, you're going to see a lot of that in our formulas, okay? Means the sum of all values, okay? So we'll recognize that a little bit later when we do the mean. Okay, here's example 1. If the data is 170, 177, 162, 158, 193, 121, then the x to the i's are the numbers. So, for example, x to the 3 means, what's your third data point? So look here, count to 3. 1 is your first one, second one, third. So your third data point equals 162. Okay? And if we're looking for the sum of it, ladies and gentlemen, if you look at that sum formula sheet, so the sum of all your data points equals, you'll notice that I starts with 1 and it ends at 6, because there's 6 total. And then you're going to sum, I apologize, you're going to sum all of them together. Okay? So if there's 6 data points, then it tells you I start at my first data point and get to my 6th data point and I add them all together. Okay? So this is a short way to write the sum of all data. Okay? The long way, if you're wanting to know, I don't want you to do the long way, but the long way is to take this and go x1 plus x2 plus x3 plus x4 plus x5 plus x6. Kind of like what we did in the warm-up, folks, when we were taking a look at getting the numerator of the mean. Okay? But I don't want you to do the long way. I prefer the short way. Okay? Right like that. Okay? All right, let's take a look at the next page. Okay, here's more notation. So look on your formula sheet, folks. This isn't me making stuff up. So just look at the mean on the formula sheet. If we have a sample, notice you've got a lowercase x with a bar over top, okay, and it says the sum of x divided by n. So what we need to remember, folks, is sum means to add up all the data points like you did in the warm-up, and n is the number of values in the sample. Okay? Whereas if we skip over to the population, notice it's a different formula, and you need to make sure you defer to one or the other on your test. Okay? Okay, and this is mu equals the sum of all data points divided by capital N. And capital N is the number in entire population. That's why you use a different letter, because it's telling us. There's a big difference, folks, if we took the results of 10 people that were surveyed to represent our school versus every student in our school. All right? Okay. Now, for the median, ladies and gentlemen, I told you it was the middle number when they're in numerical order. Okay, there's two other ways that we can take a look at it. And this is Q, meaning quartile. So this is the second quartile, that's how you pronounce it. Okay, and it's the place where 2/4 of the data lie below. So if I take all my data and I put it in order and I divide it into quarters. So if I go like this, I go Q1, meaning my first quarter, Q2, my second quarter, Q3, third quarter, and I divide it, so I separated my data into 4 quarters. Okay, Q2 occurs right here at the end of the second quarter. Okay, that is where the median occurs. Okay, the other way that we talk about median is with percentiles. Okay, 50th percentile. Okay, you will probably see this more if you do SATs or if you're placing. If you're getting an overall placement maybe for track and field or whatever, percentiles are used when you're comparing to others. SAT scores, I know they talk about percentiles to get your grade point average in the States. Okay, so percentile, you have a total of 100, right? So you can be between 0 and 100. Okay, there's a range there, and 50 is right in the middle. Okay, and if 50 is at the middle, that also means the median. Okay, all right. Let's do an example, folks, on the next page. All right, so the data below represent the hours of exercise per week in a sample of 150 people. I need you to get used to underlining those samples or population or everybody so that you know which formula to use. So the question says, find the mean and the median. Okay? Well, the problem here, folks, with finding mean and median is if you look at this chart, folks, this chart's based on intervals. Okay? So if it's intervals, then we've got to use the midpoints. And midpoint is right here. So this is the midpoint. Often when you draw graphs, sometimes you'll see they use the entire interval. Sometimes they just put a mark at the midpoint. Okay, so what's our interval length here, folks? Hopefully you recognize that our interval length is 3. So less than 3 hours, halfway between 0 and 3 is 1.5. Okay, halfway between 3 and 6 is 4.5. And we'll just fill in the chart because you're halfway between each. Okay, so in order to calculate the mean, okay, we need to take a look at the frequency of each and times it by the number of data points in each category. Okay, so the first thing I want to do is I want to get the total of my frequency. So what's my total number of people here? Okay, so F at I, if I take my calculator, add 42 plus 60 plus 21 plus 17 plus 10 plus 0, it's going to equal 150. Okay, that's going to be used later on in our formula. But in order to help us calculate the mean, I need to put these together. So I'm basically going to just take my frequency, which is 42, and times it by 1.5. Okay, which is 63. Okay, and we do the same for the rest. So go for 60 times 4.5. Okay, I'll just plug these in. I know you guys could do these in the calculator. So you're multiplying these together. Okay, so you have 157.5, 178.5, 135, and 0 times anything is 0. Okay, so what we're going to do now is total this column up, and that'll help us set up for our formula. Okay, so what I have is I have the sum of the frequency times the midpoint, which equals 804. Okay, now we're going to go and take a look over here. Okay, so this type of data, folks, is grouped data. How can you tell? Because it has intervals. Okay, it's not actual individual numbers. For example, I worked 3 hours of working out, whereas Tony worked 10 hours of working out. Didn't give you actual answers. It just gave you the grouped data, meaning that there were intervals. Okay, so look at your formula sheet for the correct formula, and notice this is the formula. Okay, now look at our formula, folks, what we have in terms of our nomenclature. So first of all, it's a sample, so I'm using lowercase x, the bar. Okay, we're going to sum the frequency times the midpoint, so that is this answer right here, which is 804. Okay, divided by the sum of the frequency, which guess what? We already have right here, okay, by 150. So it's a little different, folks. You don't have to do the long form where you put everything to on a single line, because that would be pretty tough to do that 150 times. Okay, so plug that in your calculator, folks, and you're going to approximately 5.36. If you're wondering about this dot, folks, equals as if it's exact, and if you round and you put a little dot above it. Okay, and we will, unless they tell us otherwise. Let's round to 2 decimal places, unless otherwise noted. Okay, so ladies and gentlemen, let's take a look. That was the mean. Okay, let's take a look now at the median. Okay, so the median is the middle value when they are in order. The good thing about group data, folks, is usually you'll notice the intervals are in order. Okay, so taking a look, we have a total of how many terms? We have a total of 150. So right away, I know I have an even amount, so I'm going to have to take 2 values and I'm going to have to what? Add them up and divide by 2. Okay, so this is an even number. Okay, so halfway, half of 150 is the midpoint 75. I'm going to have to take the one ahead of it, which is 76. I'm going to have to add it up and divide by 2. So again, how did I figure that out? 150 is my total. Half of it is 150 is 75, and I need one above it because it's an even number. Okay, and I'm going to add those up and divide by 2. Okay, so the median equals that. And you're going to say, okay, well, how do I know what number is 75 and 76? Well, take a look. My first 42 are in there. And if I add 42 plus 60, I know it's going to be in here. So this is going to be 102. So both my numbers have to be in here. So I have to use that data value to represent it because it's the midpoint of it. But your frequency tells you where it is. Okay, so 42 wasn't enough, so you counted to the next to the next column down, and 42 plus 60 is 102, guys. So that means that both these values are going to be 4.5. So it's going to be 4.5 plus 4.5, divide by 2, use your calculator, or just note that that's 4.5. Every time, folks, you have an even number, I need to see that work where you're adding it up and divided by 2. Okay? In this case, it happened to be the same data values to give you 4.5, but not always will it do that. Okay? And don't forget, folks, if this is a word problem, you're going to say the sample had a mean exercise time of 5.36 hours. Where do you fit on that? Are you good with that? And a median exercise time of 4.5 hours. All right. I have one more example for you with a couple formulas to make sure you noticed. Okay, so taking a look, ladies and gentlemen, on your formula sheet, Notice that we have grouped data and then we have weighted data. Okay, so group data is when you have intervals. And in order to calculate, you have to use midpoints. Have to be able to give the midpoints in order to do it, okay? All right. Whereas a weighted average is something a little different. For example, when I do your first unit test or second unit test, maybe all of your unit tests, you choose to do this. You can't just add all the numbers up and divide it by 4 categories for the KICA categories, because different categories are weighted differently. Knowledge has a different course weighting than the communication, for example. Okay, so weighted mean, just think about your KICA categories where they're different weights. Okay, so they're different weights. If you have a class, folks, where all of them are 25, then that's fine. Okay, but they're all the same percentage. But this case is not the same percentage. All right, last example, and then we're done for the day. Okay, in a dog show, obstacle is worth 25 points, obedience is worth 15, and appearance is worth 20. Who won? So again, folks, this is what we call, we have to take a look at a weighted score. Okay? All right, so you can't just add up obedience plus obstacle plus appearance because each has a different weighting. Okay, or have different point value. Okay, so we've got a German Shepherd, Bruce, and Bo a Collie. So let's do Bruce first. Okay, so we're calculating the mean, and it's a weighted mean. Okay, so how do we do this? Okay, well, first of all, we take a look. Obstacle was worth 75. You got mark a 75, but it's worth 25, so we're going to times it by 25. Plus obedience is 90. We're going to times that by 15 because that's what the points are. Plus the appearance, which is 80 times 20. And then to divide by, you got to divide by your total scores. So the obedience is out of 25 plus obstacles out of 25, obedience is out of 15, and the appearance is out of 20. Okay? So grab your calculator, folks, and on the total you should get 4,825 divided by 60, and the total answer is a weighted mean of 80.4. Now, ladies and gentlemen, if any time I go way too fast for your calculator, just simply pause the video, and then when you've got your calculation, unpause it and double check, okay? All right. Need to fit in Bo here for a little bit of room, so I got to write it a little smaller. Okay, so for Bo, we're going to do the same thing. So it's going to be 80 times 25 plus 75 times 15 plus 100 times 20, all divided by the same total, which is 60. Okay. So get your calculators going. The numerator is going to be 5,125 divided by 60, and that's going to be 85.4. So therefore, who won? Bo won. So I'm going to write that down. So therefore, Bo won because we don't know if it's a she or he, it had a higher weighted score. All right. Hopefully you liked your first statistical analysis, and please understand that the crazy symbols and letters, they'll come to you if you haven't already figured that out. And those are common on spreadsheets and everything, so you'll see them again if you decide to go into post-secondary with doing data collection or any analysis like that. All right, so here's your homework for next day, folks. Page 133, numbers 1, 3 to 5, 7 to 9, and 11 to 13. Have a great day, and see me if you need any help, especially with your calculator plugging this in. Have a great day.